So today we're going to learn how we can use the definition of a derivative to solve for a derivative. Now, as you can see from our wonderful definition that we have on screen here, we actually use the limit to find the derivative when we're using this process. So we're going to go through a few examples applying the definition of derivative, and hopefully you can understand how to do this yourself. So let's start with something basic. What if our function of x is equal to just a constant and a multiple, say 3x. Now we want to find f prime of x. That's our derivative of f of x. Let's use the definition of a derivative. So what we need first from that definition in the first part of the video is f of x plus h. Now what that means is anytime that there's an x in our f of x function, so this right here, we're going to substitute x for x plus h. So in this example, f of x plus h is equal to 3 times x plus h. And now we can start getting into our limit and finding the derivative. So we have the limit as h approaches 0 of f of x plus h minus f of x, oh that's an h, minus f of x all over h. Now let's substitute what we know for f of x plus h, f of x, and h. So we have, this is going to be equal to the limit as h approaches 0. F of x plus h, we know that that is equal to 3 times x plus h, so we're going to just distribute that 3 and write 3x plus 3h. Minus f of x, well that's just minus 3x all over h. Now we could start canceling some terms in our numerator, 3x and negative 3x. Those will cancel each other out, and what we'll be left with is the limit as h approaches 0 of 3h over h. Now we can divide, since we have an h in our numerator and denominator, we can divide 3h by h, and what we'll be left with after this is just the limit as h approaches 0 of 3. And since we don't have any h's left in our function, all we have is 3 now. We don't have to evaluate the limit. There's nothing to evaluate. All we have left is 3, and we have found that f prime of x is equal to 3. Now let's do another example. What if we were to do, let's go back, let's do the power rule. The power rule, that's a classic, right? So what if f of x is equal to x squared? We should already know this is a really easy derivative to take. X squared, the derivative is going to be equal to 2x, right? But let's pretend we don't know that yet. We need to find what f of x plus h is equal to. So that, we're going to, again, substitute x plus h into any x in our original function. So f of x plus h is going to be equal to x plus h squared. Now, let's find a derivative, f prime of x, using the limit. This is going to be equal to the limit as h approaches 0 of f of x plus h, so we know that that's x plus h squared, minus f of x all over h. Let's evaluate, let's evaluate our numerator, right? Let's make this a little simpler for us to read. So limit, and as you notice, I'm writing the limit in every single step, and that's important because we're still taking the limit. You're going to want to show this on any work that you're doing. So the limit as h approaches 0 of, well, when we multiply x plus h by itself, when we're squaring it, we get x squared plus 2hx plus h squared. Simple factoring. And now we have minus x squared all over h. Let's make our numerator simpler like we did in the first example. So x squared minus x squared, those will cancel each other out, and we'll be left with the limit as h approaches 0 of 2hx plus h squared over h. And now we can divide the terms in our numerator by h. So we have the limit as h approaches 0 of 2 plus h, 2hx divided by h is just 2x. Oh, I didn't write 2x, I wrote 2. That was my bad. So we have 2x plus h squared divided by h, that's just h. And now we're going to evaluate the limit. So as h approaches 0, we have that this is going to be equal to 2x plus 0, and we'll find in the end that f prime of x is equal to 2x, just as we knew from taking the power rule. Now let's do something not as fun. You know, the power rule, that's such an easy one to do. Let's do the quotient rule. What if f of x is equal to 1 over x? And I like this simple one, 1 over x, because as I learned in my calculus class, instead of doing the quotient rule for this problem to find f prime of x, we can just do the power rule, because 1 over x is the same thing as x to the negative 1 power. And then from doing the power rule, we know that the answer to our derivative will be negative x to the negative 2 power, right? So that's an easy way we can fact check it when we're all done with this. So, but we're not going to do power rule again for this. We're going to do quotient rule. So we have 1 over x. So that means our, oops, I lost my pen. That means our f of x plus h is equal to 1 over x plus h, because we're just substituting that in whenever we have an x in our original function. And now let's find the limit. So we have f prime of x is equal to the limit as h approaches 0 of f of x plus h, so we have 1 over x plus h, minus f of x, 1 over x, all of this divided by h. Okay, so our numerator is not so easy to subtract because we have two different denominators, but we can make this something we can subtract by just multiplying the numerator and denominator of our first fraction by the denominator of the second, and multiplying the numerator and denominator of the second fraction by the denominator of the first. And when we do that, we get the limit as h approaches 0 of, okay, so numerator times the denominator of the second, that's going to be x, and then the numerator of the second times the denominator of the first, that's going to be minus x minus h, and then when we multiply both the denominators by each other, we get x squared plus hx. Nothing that you probably haven't done before if you're learning calculus. And now all of this is divided by h. So we have a fraction, and then we're dividing that by something else. So how about instead we multiply by the reciprocal, because more often than not, multiplication is a lot nicer to do than division. So limit as h approaches 0 of, and while we're at it, instead of writing x minus h, we'll just write minus h, because the x's cancel each other out. So we have negative h over x squared plus hx times our reciprocal, so 1 over h, instead of dividing by h over 1. Now, while we're multiplying, our numerator is going to be canceled out by this denominator, right? But keep in mind, we're still keeping this negative sign right here. So now we have, this is equal to the limit as h approaches 0 of negative 1 over x squared plus hx. And we can evaluate our limit as h approaches 0. So here we're gonna shift things over right over here to the left side. And we'll have the limit. Oh, I lost my pen again. Limit as h approaches 0. And when we evaluate that here, let me actually get rid of that real quick, because we are already doing this. We're going to have negative 1 over x squared. And then when we, when we evaluate the limit, h approaches 0, the hx goes away because 0 times x is 0. So we're left with f prime of x is equal to negative 1 over x squared. And as we established in the beginning, if we had looked at this through our power rule, we also find that this is equal to negative x to the negative 2 power, which is the same thing as negative 1 over x squared.